Fourth graders have been learning about the forms of energy. In this video, we'll learn about what energy is and how we can find evidence of energy. What is energy? Have you ever heard someone say you have a lot of energy? What does that really mean? Energy is one of the most difficult concepts to understand. Many adults even have a hard time understanding and describing energy. Energy allows us to do everything in our lives, but what is it? We're going to use evidence to help us understand energy. We know that energy exists because it takes different forms. These forms of energy are easier for us to see and experience in our everyday lives. We will look for evidence of energy by understanding some of its forms, such as light, sound, heat, motion, and electrical energy. Light is a kind of energy that comes in a range of forms. Human beings can see only a small part of this range. This part is called visible light. Some things, including the sun and artificial lights, such as street lights and desk lamps, give us visible light. The energy given by most artificial lights is provided by electricity. Sound is the form of energy we hear. Every sound we hear is made when an object vibrates, making quick, tiny movements, back and forth or up and down. When an object vibrates, the air around it vibrates too. These vibrations of the air travel outward in all directions from the object. When the vibrations enter our ears, the brain interprets them as sounds. Heat is one of the most important forms of energy. We can sense heat through nerve endings in our skin. We use heat to do work and to make our lives better. For example, we use heat to warm our homes and cook our food. Heat runs machines such as cars, airplanes, and ships. Heat causes big machines called turbines to spin and make electricity. The sun is our most important source of heat. Heat also comes from deep inside Earth through volcanoes and hot springs that shoot up into the air. Motion energy is also called kinetic energy. To be in motion means to move. Anytime objects move, it has motion energy. Electricity is a kind of energy. We use electricity to make things work. It runs lights, television sets, microwave ovens, computers, and many other machines. Inventors and scientists learned how to make large amounts of electric energy. Then they found ways to use that energy to make light and heat. They invented electric devices that allowed people to talk across great distances and to handle information quickly.
In the mid-1700s, Ben Franklin figured out the nature of electricity, paving the way for many more inventions. Electricity provides a way to store and distribute energy generated in a variety of ways.
Arcs of electricity jump from a rod to a power line, then quick shots of city lights, glowing signs, bolts of lightning, and a refrigerator.
We live in an electric world. Electricity flows through us and around us. It dances in the sky as lightning and pulses through our bodies as signals between the cells and organs.
A humanoid robot turns its head.
We are always finding new ways to use electricity.
A person picks up a hairdryer, then vintage footage of lights glowing on a tower.
Coney Island in Brooklyn was one of the first places to have electric lights installed. Thomas Edison brought his electric invention there in 1903, amazing people with a dazzling light display. Over a century later, Coney Island is still an electric playground with rides and games covered in flashing lights.
Bolts of electricity wriggle in a tube.
Electricity may be the most common form of energy we use. In fact, you are using it right now. But what is this incredible energy, and how does it work?
On a model, electrons orbit a nucleus.
The answer lies in the atom. Atoms are made up of neutrons, protons, and electrons. Neutrons have no charge, and protons are positively charged. Both stay in the nucleus, the center of an atom. Electrons are negatively charged, and they can jump from one atom to another. Electricity is the interaction of electrons and protons. Electric current is the movement of electrons from atom to atom.
Squiggly bolts of lightning zigzag from the ground up through the sky.
Lightning is a form of electric current. It is spectacular and powerful, and it has the same characteristics as electricity.
Animated negative particles hang above a positively charged surface.
As electrons build up on an object, it becomes negatively charged. Electrons can jump from one negatively charged object to a positively charged one in a discharge, which balances the charges of both objects.
A bolt runs from a cloud down to the ground.
Energy builds up as the charges separate. The energy used when the electrons move during the discharge is the voltage, or potential difference. This is measured in volts.
A wire-like filament glows inside a blue light bulb.
Think of the electrons flowing through wires as if they were water flowing through pipes. In a squirt gun, water under pressure moves fast, but to put out a fire, it's not the best choice. You need a fire hose that can move a lot of water. The water pressure is like the voltage in electricity. The amount of water is like electrical current, which is measured in amperes or amps. Electrical measurements are based on numbers of electrons. A light bulb that uses 1 amp of current has 16 quintillion electrons moving past a single point in the wire every second. We use the properties of electricity to generate current in power plants.
A barrel-shaped turbine spins.
An energy source, such as fossil fuel, moving water, or wind, is harnessed to spin a turbine, and the turbine spins a magnet near a coil of metal wire. The movement of the magnet near the coil of wire causes electrons to move through the wire. This current flows through power lines to the outlets of electric power customers. When the direction of the current is changed several times a second, as it is in the lines of power plants, the electricity is called alternating current, or AC electricity. Electrons flow easily through copper and other materials called conductors. Rubber resists the flow of electrons, and materials like this are called insulators. Electric wires are made with conductors. High-power wires, often called high-voltage wires, are usually made with aluminum. It doesn't conduct as well as copper, but it's much lighter.
The wires connect to tall towers.
Lightweight is important for high-voltage wires because they are very thick and stretch over hundreds of miles.
A man sits on a platform connected to the base of a small helicopter.
Maintaining power lines can be dangerous work. Lines must be repaired, often without shutting down the power.
This is the span that we want. I'm going to go ahead and come down in between the two 500 kV lines, and we're going to find the damaged location, and we'll get ready to start work.
Aerial crews can repair live wires quickly in relative safety, but the threat of electrocution is always present.
The repairman holds a rod near the wire, and arcs jump to it.
Less than 1 amp can stop the human heart. The high-amp electricity flowing through these power lines could be deadly. Electricity has transformed our lives. Computers, automobiles, robots, and countless other inventions would not have been possible without this source of power.
A view from a space shuttle captures Earth's blue horizon.
The future of technology will depend on finding new ways to harness and generate all-powerful electricity.
Most of the electric energy we use comes from power plants. Most power plants burn fuels such as coal, oil, or natural gas. These fuels are also known as fossil fuels and come from the earth. Once they are used once, they cannot be used again, and there is a limited supply of these fossil fuels. We call these non-renewable resources.
A world without energy would be a cold, dark place. Luckily, early humans discovered that fire could light up their lives. We still use fire or combustion, but wood doesn't have enough energy to power today's coolest inventions. Fossil fuels, which contain much more energy than wood, got everyone fired up with new possibilities. The enormous energy of fossil fuels comes from tiny hydrocarbon molecules that contain only hydrogen and carbon atoms. Fossil fuels are currently the world's primary energy source, but finding them and obtaining them can be quite difficult.
A suspension bridge lights up, a ballet dancer leaps on stage, a race car zips around a track. Words read fossil fuels.
Two fossil fuels, coal and oil, provide most of the daily energy that heats our homes, powers our cars, and generates our electricity.
Steam rises from stacks.
Since the late 18th century, we have increased our consumption of fossil fuels. With the invention of steam engines, the demand for coal skyrocketed.
Airliners taxi down a runway.
Our fuel needs for transportation and heat drive oil exploration in the harshest corners of the planet.
An offshore drilling rig stands several stories above the water.
This is the most extreme drilling rig in the world, the Eric Raud. With the latest generation of offshore rigs, few oil and gas reserves are beyond reach. The Eric Raud can drill for oil in deeper water and rougher weather than any drilling rig in history.
Ocean swells rise and fall.
Exploration for oil and gas has moved from land to sea. The oil industry has devised oil rigs or massive drilling platforms that stand on the ocean floor and drill deep beneath the seabed. Until recently, offshore rigs have been restricted to shallow water, limited by the length of their legs. But a new generation of rigs floats. The Eric Raud drills in extremely deep water.
Sandra Skifio, captain of Eric Raud.
And we are doing the same thing in deeper water with more high-tech equipment, with a bigger derrick, with everything is blown up.
It can't be fixed to the ocean floor at great depths, so it floats on two massive submerged pontoons. It began its first voyage off the coast of Canada in 2002. Its mission? To drill for oil where no one had dared to drill before. The Eric Raud is a self-contained floating city, connected to the outside world by boat and helicopter.
She's so strongly built, and she's equipped with so much power, so much high-tech DP equipment and thrusters and generators that we are powered to run Halifax City.
Everything on board is designed around the massive drill at the center.
And it's all turning around that drill in the middle here to go down and make a hole and find oil. That's the main goal, and everything around it is built for that reason.
The Eric Raud will search for oil in rough seas up to 10,000 feet deep, where reserves have been previously out of reach. Its semi-submersible design is more stable than anchored rigs in rough weather. A system of 6 giant thrusters holds the rig in position while drilling. This makes the Eric Raud the most versatile oil drilling exploration system in the world.
A wheel lined with scoops digs up earth.
Not to be outdone, the coal industry has invested billions to invent and build the most technologically advanced excavating machines in the world.
The wheel resembles a saw blade.
In the U.S., coal produces more than half of our electrical power and accounts for 22% of our overall energy consumption. Coal is the most abundant fossil fuel on Earth and fueled much of the Industrial Revolution in the 18th and 19th centuries.
A shovel is attached to a crane arm.
The early steam shovels have since been replaced in coal mining by more mechanized means of production.
The massive bucket wheel fades to a cluster of European homes.
Some areas of the world, such as Germany, have abundant reserves of coal.
Dr. Joachim Witzel.
40,000 people with shovels to replace the excavator and to make the same amount of material each day as the excavator does.
The bucket wheel excavator was developed to extract it from the ground. Bucket wheel excavators mine coal at high rates of speed, but are also more environmentally responsible machines. As they remove large deposits of coal from the mine pits, they redistribute topsoil and other materials for reuse.
People gaze at a river.
Coal mining is vital to the economy of the United States and many other countries, such as Germany. It provides a homegrown energy source for electrical power plants. Coal continues to supply most of the energy in the United States. The use of coal and oil has added billions of tons of carbon dioxide and other pollutants to our atmosphere. Yet they remain the most economically efficient sources of energy.
Scientists are trying to come up with other ways of getting electric energy, for example, from the sun or the wind. This is a wind turbine. It takes motion energy from the wind and eventually converts it into electric energy. This is a solar farm. It takes light energy from the sun and eventually converts it into electric energy. This is a dam. It takes motion energy from the water and eventually converts it into electric energy.
Hey Team BCPS, this is Mr. Tom from the Office of Science. I'm here to talk to you about a very important celebration that was first celebrated back in 1970. Now 1970 was a very important year for many reasons. The Baltimore Orioles won the World Series. The Beatles broke up. A space probe landed on Venus. Kermit the Frog was first quoted as saying those famous 5 words. It's not easy being green. And you know what? Kermit is right. It's not always easy being green. But we've got a very special celebration coming up very soon. We want you to be a part of it because 1970 was when the very first Earth Day was celebrated. In fact, April 22nd, 2020 is the 50th anniversary of Earth Day. Yay, Earth Day! Celebrate this important anniversary with us all next week by participating in activities that promote environmental activism. The Office of Science is producing a menu of activities that we'll be sharing online to celebrate this anniversary. So some of the items you can complete independently, some with your siblings, and some can be completed with your entire family. So use social media such as Facebook, Instagram, or Twitter to promote what Team BCPS is accomplishing to celebrate Earth Day. Because even though we're apart, together, Team BCPS can make a difference.
Did you know that the energy of waterfalls and rivers can be converted to electricity? Inventors have been exploiting the power of water for centuries. Here at Hoover Dam, water rushes through these giant turbines to generate massive amounts of electricity, enough to power all of the surrounding area.
An ocean wave rushes in and a word reads hydroelectric.
Have you ever stood in the ocean and been knocked over by the force of a wave? Imagine the amount of energy in a wall of water hundreds of feet high, with millions of gallons behind it. It may seem impossible to tame such an awesome force, but people have depended on the power of water for millennia.
A wooden wheel turns.
The water wheel, one of the first inventions that captured this power, converts the energy of water flowing in streams and rivers into mechanical energy. The Greeks invented the first water wheel around 4000 BC. Since then, the device has powered the development of agriculture and manufacturing around the world. Toward the end of the 19th century, the demand for electrical energy rose. New ideas for generating electricity were needed, and the energy of moving water caught the eye of a paper manufacturer named H.F. Rogers. He invented and built the world's first hydroelectric dam in the town of Appleton, Wisconsin in 1882. Driven only by the force of the local Fox River, the dam generated enough electricity to power Rogers' house and his paper factory. Hydroelectric dams today operate on principles similar to the Appleton Dam, but they are designed to produce much more electricity. A modern dam usually blocks a river with a concrete wall several hundred feet high. This floods the area around the dam and creates an artificial lake. The water held behind a dam has a tremendous amount of potential energy, which can be converted to kinetic energy, or the energy of an object in motion. In a hydroelectric dam, the force of gravity pulls water down through large tubes called penstocks. In this way, the potential energy of the lake water becomes kinetic energy as it begins to move. As the water flows through the penstocks, it spins turbines. The turbines power electric generators which spin magnets in metal coils. This produces an electric current that is distributed on a power grid. The water current produces a current of electricity. Hoover Dam is one of the world's most famous hydroelectric dams. It is an excellent example of how to harness efficient, renewable, and clean hydroelectric energy. Completed in 1936, the dam stabilized the Colorado River and generated reliable and clean energy for Arizona, Nevada, and Southern California. It is still producing electricity today. Already in widespread use across the United States, hydroelectric power is becoming increasingly important in China and other parts of the world. China's Yangtze River is the longest river in Asia and the third longest in the world. The Three Gorges Dam is being constructed to harness the river's power and generate electricity. As China's industry grows, so does its energy consumption. When all 26 of the dam's hydroelectric generators are running, the dam will be able to generate 18,000 megawatts of electricity. That's more than 8 times the electricity generated by Hoover Dam. But the energy produced by the Three Gorges Dam comes with a heavy price. Building the dam created a body of water nearly 600 feet deep and as long as Lake Superior. This artificial lake destroyed 13 major cities, as well as hundreds of towns and villages, some of them thousands of years old. Family homes and rural settings have been given up for rows of concrete dwellings in new towns. Only time will tell how people will adapt to their new landscape. But one thing is clear: the power of water has transformed lives all over the world. From the small industrial town of Appleton to the sweeping desert landscape, the energy of water flows through society with incredible force.
Now that you understand more about the different forms of energy and how we know energy is real, take a look around your house and see if you can identify different forms of energy in use throughout your house every day. Look for examples of light, electric, motion, heat, and sound energy throughout your home. Think about how our lives would be different without these forms of energy.